In this video, I'm going to be covering question 5, part B from the 2019 AP Calculus AB free response, no calculator allowed portion of the exam. If you want to see answers for A, B, and C, I do them all in their own separate videos, so watch my other videos to see the answers to the other parts of this problem. So looking at B here, the region R enclosed by the base of this is the base of the solid up above. For the solid at each cross section perpendicular, when you see that language there, this is really like bells and whistles are going off that you should be doing a cross-sectional area to find the volume of the solid. And that means that what you're looking at is this volumes of cross-sectional area formula, which is just an antiderivative formula you got to have down. So this would be the integral from a to b of whatever your area formula is dx. This problem is telling us that our area formula here is actually this formula given to us. The thing that kind of throws you at first when you see this problem is usually when you do these cross-sectional area problems, they don't give you the area formula straight up. Normally what's happening is they tell you that this region in between here is the bottom of some other shape. It's the bottom of a square, or it's the diameter of a half circle. This one was almost too easy. It was hard because they just straight up gave us the area formula here. So as long as we know this cross-sectional area setup, we basically got this problem done for us. So setting it up now, what we would have gotten was the integral from a, which would have been the left-hand side over here. That would have been at x equals 0. To our b value, which would have been the other side of this region, and that would have been at x equals 2. And then we have our area formula here. This is 1 over x plus 3 dx. When we come to do this problem, now we just have a really pretty straightforward definite integral in front of us. The way it looks right now, it would actually be a u substitution to get through it. The more of these you do, the quicker you might be able to just kind of get to the final answer quick and easy. But we're not going to make any assumptions that you've got that, you identify it that quickly. So from here, what you would do is you would say, okay, well, I can't take the antiderivative of this following a power rule, following a special case, just straight up right now. So if it's not one of those two things, then what you're looking at is going to be a u substitution. So let's run this process. Step 1 of the u substitution process is to go ahead and choose the u value. When I go to choose my u, I've got sort of a priority list that I go through. The first thing I go looking for is a natural log if it's available to me. If I don't see a natural log in the problem, then I choose what I would call the inside piece, as if I was doing a chain rule problem. So something that's inside a set of parentheses, maybe something that's inside a trig function. If I don't see that there, then I choose the bottom of a fraction. And so as we look through this problem, I would start at the top and I would say, well, I don't have a natural log, so that's not what I'm looking at. I don't have an inside piece, so that wouldn't be what I want to look for. So I'm down to my third option, which would be the bottom of a fraction. So here, the bottom of the fraction would be what I'm looking for. So u would equal x plus 3. Once you choose your u, the next part of the process is always the same. You start by taking the derivative of that. So du dx, and you always want to use this differential notation. Du dx, du dy, whatever the variable is you've got in the problem. So taking the derivative of x, that would get me 1. The derivative of 3 would go away because it's the derivative of a constant. Then the next part of the process that you want to go through is we want to resolve this because we need to get rid of this dx. When we go to substitute back into this problem, we need the whole problem to be talking the language of u, and that includes turning that dx into a du. So to do that, this is just an algebra problem. You're going to solve this derivative to get dx by itself. So here the algebra is pretty straightforward. I multiply both sides by dx to get it out of the bottom. It cancels out on that side and I end up with du equals 1 times dx is just dx. Normally it's more of an equation, but here we're done pretty quickly. Then this u substitution problem has one additional step. Those first 3 are always what you do, but because we have bounds on this definite integral up here, we would also need to adjust the bounds because those are x values, right? And we need this whole equation to be talking nothing but the language of u. To do that adjustment, what you do is you take your equation for u. So you had u equals x plus 3. And now we're going to plug these x values into that equation to get out our new bounds. So on the lower bound, I had when x equals 0, I plug into this equation. I would say u equals, and instead of x, I plug in 0 plus 3. So there's my new lower bound. And then when x equals 2, I plug into this equation 2 plus 3, replacing that x, and I end up with 5, so that's my new upper bound. Once I've done that, now I'm ready to go back and do the substitution part. So I'm going to take and I'm going to substitute in u, I'm going to substitute in for dx, and I'm going to substitute in my bounds here. So working my way through this, it's either one of the things I substitute for or it sticks around. So x equals 0 is going to become 3. X equals 2 is going to become 5, and then I've got 1 over, and all that stuff on the bottom is now u, and then dx becomes du. At this point in the process, usually if you clean the thing up, ideally you get it down to a problem that is now something you do know how to take the antiderivative of. I call this your reward for all your hard work, a brand new math problem. So hopefully we know how to take the antiderivative of this problem. And sure enough, this is one of the special cases that you just have to be able to identify when you see it. So this is a special case whenever you've got a number over x to the first, and that is the only time this special case comes into play. A number over x to the first, this came from the natural log. So this is whatever that number is on top times the natural log of the absolute value of x. And when you don't have bounds, you would put a plus c. So here, there's my special case. So my number on top, my a value is a 1, so I don't really need to multiply by 1. So this would be the natural log of the absolute value of x. And because I have bounds on here, actually it's not x, is it? It's u. Sorry, I was just going off of that special case. The natural log of u, and then this is from u equals 3 to u equals 5. And now from here, we're just going to go through and do what I call top minus bottom, right? To finish this out, when you've got a definite integral, you plug in the top value and subtract off the bottom value plugged in. And because we turned everything into talking the language of u, we don't have to backwards substitute it all. So this would be the natural log of 5 plugged in for u minus the natural log of 3. And because you don't have a calculator to work from on this, you really can leave your final answer just like that. So working our way back through this, you would have gotten 1 point for getting all the way down to this integral being correct, and you would have got a second point from plugging the pieces in and getting out that final answer. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.